Okay, now let's look at some problems that require a few more steps that deal with the absolute value function. Now, the process when working with the absolute value function is you want to isolate the absolute value function. So I want to move everything away from the absolute value and not worry necessarily what's on the inside of it until after I've isolated it. So, moving, adding, and subtracting first. So I got the plus 10. I got to subtract 10 from both sides to make that go to the other side. So we have negative 8. Make sure you write the absolute value symbol every time. Equals negative 70 minus 10 is negative 80. And then now we got to take and remove the multiplication of the negative 8 on the outside of the absolute value. You do not want to distribute or multiply anything inside of the absolute value. You don't want to distribute that. So I want to leave everything off of it. So now this gives me the absolute value of n is equal to positive 10. And so remember our rule for the absolute value. The absolute value has to equal values that are 0 or larger, and so this condition is met because it says it equals 10. So now we can write two conditions for n. So n could equal positive 10, or n could equal negative 10, because the absolute value of both of those numbers makes 10. So absolute value of b plus 8 is equal to negative 1. There's nothing on the outside of the absolute value to move, so it's already isolated. So here we look at what does the absolute value equal since it's isolated and there's nothing else on the outside to move. Well, in this problem it says it equals negative 1. That's not possible because the smallest number of the absolute value can output is 0, so this one is no solution. The absolute value of 8x plus 5 minus 10 is equal to 9. All right, so we need to isolate that absolute value. So I'm going to move the addition and subtraction on the outside of the absolute value first. So I'm going to add the 10 to the other side. And it's going to give me the absolute value of 8x plus 5 is equal to 19. So again, we don't want to put that positive 5 and that minus 10 together and call it minus 5. Sometimes it'll work out, maybe, but for the absolute value function, you want to leave what's on the inside alone until you get everything outside of the absolute value on the other side of the equation. So now we're at this line, and we look, and we have the absolute value of some expression has to equal positive 19. Well, that is possible. So now we're ready to make our two conditions for what the inside could be. So remember that the absolute value of positive 19 is equal to positive 19. So I'm going to set the inside equal to positive 19. And also the absolute value of negative 19 makes positive 19. So I make two little math problems here that I work to solve. So now I'm going to isolate the x. So I'm going to minus 5 from both sides. And I'm going to work both of these equations kind of at the same time. All right, so this first equation on the left will make 8x equals 14. And the equation over here on the right would make 8x equals negative 24. And now we're ready to divide by the 8 that's timesing to the x everywhere. And so we're going to get x is equal to 14 over 8, which I can reduce that. That's going to make, both numbers are even, so 7 over 4. And this one, negative 24 divided by 8 is negative 3. All right, new problem here. So I see I have the absolute value on one side, which means in order for me to solve it, I have to isolate the absolute value. So I look to move any adding and subtracting on the outside of the absolute value first. So I'm going to move the minus 10 to the other side, which means I got to add it to both sides. It's going to give me negative 6 times the absolute value of 6n plus 2 is equal to negative 12. And I still have that negative 6 that I need to move. So I'm going to divide by negative 6 on both sides. Gives me the absolute value of 6n, make that a little bigger, plus 2 is equal to positive 2. So now we confirm that the absolute value of an expression has to equal a number that's 0 or bigger. 2 is bigger than 0, so we're good to go. Now we make our two little math problems here because the absolute value of both positive 2 and negative 2 equals positive 2. So I say 6n plus 2 is equal to positive 2, and 6n plus 2 is equal to negative 2. And now we work to solve, and I'm going to kind of work both of those equations at the same time. So I'd have to move the plus 2 to the other side, so I got a minus 2 on both sides. So I'm going to have, this first expression is going to be 6n equals 0, and the second expression becomes 6n equals negative 4. And lastly, we divide by the 6. So this left side, n equals 0 divided by 6 is 0. Some people get tripped up on that. And the second expression, I divide both sides by 6. And we have n equals negative 4 over 6, which both of those are even numbers, so I could divide them by 2, negative 2 thirds.